Well, hey there kiddos, and welcome to your video over linear parent function. These notes that I'm about to do look slightly different than what's in your packet. The first three questions that you have on your notes are not part of this. Mine starts with number 1, but it's really your number 4. So you need to turn to your question number 4. That's where we're going to start. So we're talking about linear functions, which are straight lines, and so all linear functions are part of a family of functions. They're just transformations of the most basic function in this family, which is called the parent function, and we call it the linear parent function. Whoops. And it's called the parent function because, like it says in that sentence, it's the most basic of the functions. It has a very simple slope, it has a very simple y-intercept, and then every other straight line that we ever draw or create or graph on a graph is a transformation of this. So it's either a slide or a reflection, or you've talked about transformations before. And so that's all that any linear function is. It's all based on this linear parent function. And so it's the mama, if you will. It's the mom function, and all of the other ones we do are the babies or the children. And so it can be written this way. This is the equation. It's just y equals x. And this is what the graph looks like. So it's an increasing graph, has a y-intercept of 0, 0, so it goes right through the origin. Pardon me. And we're going to talk about the slope and all of that in just a minute. But number 1 here just wants the domain and range of the parent function. Well, this is a straight line that has arrows on either end, which means that it goes to the left and to the right forever. And so my domain is just going to be all real numbers. So it's that fancy R that we draw. And the range goes from the bottom to the top forever because of those arrows. And so my range is also all real numbers. It's got the arrows on the ends. It's a straight line. It goes left, right, up, down forever. So number 2 says, what do you notice about the slope of the parent function? Well, you can either do it from the graph, and you can find 2 pretty points and do your rise over run. So you see that it's 1 over 1, or you can look at the equation that I gave you, the y equals x, and you'll see that the x is by itself, which means there's an invisible 1 right here hanging out in front of it. And so the slope of the parent function is equal to 1. And then number 3 says, what do you notice about the y-intercept of the parent function? Well, the y-intercept of the parent function is at the origin. It's at 0, 0. And so that's why it's the most basic one. It has a slope of 1 and a y-intercept of 0, and so the equation is just y equals x. And there's nothing else to know. Now that equation, y equals x, is one you're going to need to commit to memory. You're going to need to know that the linear parent function is y equals x. You're going to be asked that question, and you need to be able to recite it back to me. Okay, so now we're going to talk about a few other questions. These right here are also, my numbers are all messed up, but these are also on your notes, these 3 pictures, but it doesn't have this part underneath. And so you can just squeeze it in if you need to. But we're going to determine whether or not they're linear, if it's linear or not, and then we're going to find the domain and the range. And so number 4 here, is it linear or not? Well, it's not linear, and the reason why is because it's a curve. It's not a straight line. If you want to explain your reasoning, there it is. It doesn't make a straight line, it's a curve. And this curve has a name we'll start talking about when we get to these types of functions, but we're going to do domain and range for it first. So domain, remember, goes from left to right, and this curve, this graph, has arrows on both sides, so it goes to the left forever and to the right forever, so my domain is just all real numbers. My range, though, goes from the bottom to the top, and down here at the bottom of my graph, it starts at -4. And so it goes from -4 all the way up to infinity because these arrows point up. And so it starts at -4 and goes to infinity. So this is one way to write the problem. Another way that you will see it is that we'll just do this part because it goes to infinity. We don't need the rest of it. And so they will just write this part, but they will write it in reverse order. They'll put the y first, which will change this symbol. So it says that y is everything greater than or equal to -4, which means it starts at -4 and goes up. Well, that's what happens to my graph. So either one of these statements is fine. You can write the big long inequality, or you can do the shortened version. So this next question here, obviously that is not linear. It's not a straight line. It's got a little curvy thing happening. And again, It's got arrows on the ends. So when we talk about the domain, this goes to the left and to the right forever, just like our straight line does. So the domain is all real numbers. The arrows also point down and up forever, so the range is also all real numbers. So this one right here, obviously it's linear, it makes a straight line. You can see it is a straight line, and because it has the arrows on the ends, just like the parent function up here when we did our domain and range, that one right there has arrows on the ends. It's also all real numbers for the domain and the range because it goes to the left and to the right forever. It also goes down and up forever. So this last question here says to determine which of the following functions are linear and explain your reasoning. Well, the easiest way to do this, hold on one second. The easiest way to do this is to grab your calculator, and we need to graph these on our calculator, and then just look at them. So if you will go find your calculator, I will get mine out, and then we'll go through this together. Okay, so the first one we have says y equals 2/3 x plus 14. So that's the first thing that we're going to do. We're going to go to the button that says y equals, and we're going to type in, we're going to clear out anything that's there, and we're going to type in that 2/3 x plus 14. So to make the 2/3 the fraction, I'm going to do alpha y equals, option 1 is my fraction, so I can do 2 over 3x plus 14. I'm going to graph it and look at it. So I'm going to hit graph, and looky there, that makes a straight line. So I have a straight line, and if you want to make for sure that it's really a straight line, you can go over here and you can go to zoom. You can press the zoom button, and you can choose option 3, zoom out. And you can move your cursor up and to the left just a little because I want to see more of this part, and then hit enter, and it will reset until you can see more of the graph now. And so it is definitely a straight line, and so this one is linear. So I'm going to put a check mark next to it because it's one of the linear ones. Now number 2 here is a little different because number 2 doesn't equal y, it equals -3. So the first thing I need to do is get this -3 to the other side, because I need it to equal 0 or equal y, either one. But it can't equal -3. It's got to be a 0 or a y. So I'm going to add 3 to both sides. So this is really 3x plus 5x squared plus 3 is equal to 0. And so now I can put that in my calculator. So I'll go back to y equals. I'll clear that out. And so I have 3x plus 5x squared. To get squared, you push this little button right here that says x squared. It'll automatically put the 2, and then plus 3. And then we're going to graph that one. I'm going to reset my window back to normal though. So instead of pressing graph, I'm going to press zoom and the number 6. It will graph for me, but it'll reset my window back to a normal window. And so there's my graph, and you can see that's not a straight line. It makes that curvy U shape that we saw earlier. So this one's not linear. So let's look at number 3. We got to plug that one in. It is set to equal to y, so we can do that. So we go back to y equals, clear that out, and we're going to type in 2x to the third. So here's how you do that. You do 2x, and then to get to the third power, you press this little housetop caret button right here, and it will make your exponent. So 2x to the third, then hit the right arrow to get out of the exponent, plus 3x squared minus x. And so then we'll graph that. Takes a while to draw sometimes. And you can see again, that's not a straight line. It looks like that other one that we had that was this loop-de-loop curvy thing. It's definitely not linear, so that one's not linear either. So now let's look at number 4. I have 2x plus 5 plus 2x, so we're going to put that into our calculator. Y equals, I can do 2x plus 5 plus 2x, and I can graph that and look at it. And that one is a straight line. And so now I have a straight line for this one, and for 1 and for 4, but the other 2 not. So if I look at my answer choices, 1 and 4 are straight lines. So what I want you to recognize, since we just went through this and graphed them all, the 2 that made straight lines, if you look at the x variable on it, on both of them. They were just x. There was no exponent involved. And so I had this one had two x's, but neither one of them had an exponent. If you look at the two that were not linear, you had exponents. This one was squared, this one had a cubed and a squared, but there were exponents. When you start adding exponents to the x's, you start getting curves on your graph instead of straight lines. So that's what I want you to notice about that. So when you get asked this question later and you don't have a calculator in front of you, the easiest way to tell is x all by itself with no exponents, that's going to be linear. And x over there with exponents, it's going to be something other than linear. So we'll practice this when you guys come to class tomorrow, and I will see you then.